Good morning, all of you. Welcome to the Good Samaritan School online classes of mathematics conducted by Chandan Kumar. Welcome to all of you. Today we are going to do some problems based on the properties of definite integral, exercise 7.11 of chapter 7, class 12th. In the first question, the question I did is I is equal to, I stands for integration of 0 to pi by 2 cos raised to the power 5x dx upon sine raised to the power 5x plus cos raised to the power 5x. Now using the concept integration 0 to a f of x dx is equal to 0 to a f of a minus x dx, I get in the place of x I have to substitute a minus x, which is pi by 2 minus x. Now I is equal to 0 to pi by 2 cos 5 cos raised to the power 5 pi by 2 minus x dx upon sine raised to the power 5 pi by 2 minus x plus cos raised to the power 5 pi by 2 minus x, which give us I is equal to 0 to pi by 2 sine to the power 5x, which is because of cos 90 minus theta, which gives us sine theta, and similarly sine 90 minus theta gives us cos theta. So we get I is equal to 0 to pi by 2 sine of 5x sine raised to the power 5x upon cos raised to the power 5x plus sine raised to the power 5x. Now adding this part and the first part, I get I plus I becomes 2i is equal to integration of 0 to pi by 2 cos raised to the power 5x plus sine raised to the power 5x upon the same function, which will eliminate and then give us 1. Now the integration of 1 is x. Substituting the limit, I got pi by 2 minus 0. 2i is equal to pi by 2 and the value of I is pi by 4. So in this question I have applied the concept of 0 to a f of x dx is equal to 0 to a f of a minus x. Now in the second question, the question is I is equal to integration minus 5 to 5 mod of x plus 2 dx. Whenever you see a mod question, what you need to do, just put the function which is in mod equal to 0, which will give us x plus 2 is equal to 0 and the value of x is minus 2. Now we get the interval minus 5 to minus 2 and minus 2 to 5. Now for these interval, what I need to do, I need to break this integration into two parts. The first one is minus 5 to minus 2 and the second one is minus 2 to 5. Now if I substitute a value between minus 5 and minus 2 in the function given in the mod, I will see I will get a negative value. That's why in the first part I have put it a negative sign, and in the second part if I put a value between minus 2 and 5 I will get a positive value, so I have not put it any sign there. Now integrating as per the general rule, the integration of x is x square by 2, the integration of 2 is 2x, and then we have to substitute the value minus 2 and minus 5, which is f of b minus f of a. In the second case, similarly the integration of x is x square by 2, the integration of 2 is 2x, again we have to substitute the value for 5 and minus 2. Substituting the value minus 2 and minus 5, and in the second part 5 and 2, and solving, I will get the answer I equal to 29. You can see the calculation and you can do it yourself also. Now in the third question, which is integration of 0 to 1 x multiply 1 minus x whole to the power n dx. Applying with substitution method, put 1 minus x equal to t, which will gives us minus dx is equal to dt. Then dx is equal to minus of dt. Taking this minus out of the integration, we have minus of integration 0 to 1, putting the value of x in terms of t, which is 1 minus t, and putting the value of 1 minus x as t to the power n dt. Multiplying individually, I get minus of integration 0 to 1 t to the power n dt minus minus plus 0 to 1 integration t to the power n plus 1. Now applying the power rule, which is x to the power n dx integration is equal to x to the power n plus 1 upon n plus 1, I get minus of t to the power n plus 1 upon n plus 1, substituting the value 1 and 0 in that, plus t to the power n plus 2 upon n plus 2, substituting the value 1 and 0 there. Before substituting, I have to put the value of t in terms of x again, because the range is given as per the value of x. So again I have substituted t equal to 1 minus x and then substituting the value 1 and 0. When I put 1, I got the function completely 0, because 1 minus 1 equal to 0. And when I put 0, I got the condition minus of minus 1 upon n plus 1 plus minus of 1 upon n plus 2, which gives us 1 upon n plus 1 minus 1 upon n plus 2. Taking the LCM and then simplifying, I got the answer 1 upon n plus 2 multiplied by n plus 1. So in both these questions, I have applied the general concepts. Please see the calculation carefully. Now in this question, I is equal to integration of 0 to pi by 4 log of 1 plus 10x dx. In this question, using the concept of 0 to a f of x dx is equal to 0 to a f of a minus x dx, I have applied the concept here, which will give us I is equal to integration of 0 to pi by 4 log 1 plus 10 into pi by 4 minus x, which is 10 of a minus b. Applying the formula 10a minus 10b upon 1 plus 10a 10b, we get I is equal to integration 0 to pi by 4 log of 1 plus 1 minus 10x upon 1 plus 10x. Simplifying it by taking the LCM, I get I is equal to 0 to the power 0 integration 0 to pi by 4 log 2 upon 1 plus 10x. Now this is in the form of log a by b, so just separating it, we get log a minus log b, which is integration is equal to 0 to pi by 4 log 2 dx minus integration of 0 to pi by 4 log of 1 plus 10x. Now we see the question is repeating in this last line, so in that place I have inserted I. Now this goes to the left side and becomes 2i. Now log 2 is taken outside and the integration of dx is x. Substituting the value pi by 4 and 0, we get pi by 4 log 2. So the final answer is I is equal to pi by 8 log 2. In the next question is integration of minus pi by 2 to pi by 2 sine raised to the power 7x dx. Now this is in the form of minus a to a f of x dx. Now if this function is an odd function, the integration part should be equal to 0. Now if we apply sine raised to the power 7 of minus x, we get minus sine raised to the power 7x, which proves that this is an odd function. If the minus sign does not come, it is an even function. Then we have a separate rule for that, but this is an odd function, so for that the integration of the whole term should be equal to 0. Now in the next question, which is the integration is equal to 0 to a under root x upon under root x plus under root a minus x, again applying the same format, which is 0 to a f of x dx is equal to 0 to a f of a minus x. Applying both in numerator and denominator, I get I is equal to 0 to a under root of a minus x in place of root x, and down also in place of root x I got under root of a minus x, and in place of under root a minus x I got under root x by calculation. Then adding both, we get 2i is equal to integration of 0 to a 1 dx, because both the values cancel each other, which gives us x, and then substituting the value I get I equal to a by 2. So the most important concept is this rule 0 to a f of x dx is equal to 0 to a f of a minus x. Now the most important problem of this chapter, this exercise, which is I is equal to 0 to pi log of 1 plus cos x dx. Now what I did, in place of 1 plus cos x, using the concept of half angle property, I have applied 2 cos square x by 2. Now log AB is equal to log A plus log B, so I have written 0 to pi integration log 2 plus log cos square x by 2, which then I have separated individually, 0 to pi log 2 dx. Now since it is in the square function, I have taken 2 ahead of the log, so 0 to pi 2 log cos x by 2. So the integration I got, I is equal to pi log 2. When I integrated log 2 dx, I got pi. So the integration is pi log 2 plus 2 is taken out and the whole is taken as I1. Now doing the integration of I1 individually, I get I1 is equal to integration 0 to pi 2 log cos x by 2. Using the substitution method, put x by 2 equal to t, so the differentiation dx is equal to 2 dt. Now changing the limit, at x equal to 0, t is also 0, at x equal to pi, t is pi by 2. Now I1 is equal to 0 to pi by 2 log cos t multiply by 2 dt. Now taking 2 outside, I get log cos t dt, which I write like that, log cos x and dx, because f of x dx is equal to f of t dt, the first rule of definite integral. Now hence from first, the answer is I is equal to pi log 2, and this 2 and that 2 multiply becomes 4, integration of 0 to pi by 2 log cos x. Now solving it as per the example given in the book, we get pi by 2 pi log 2 plus 4 multiplied by minus pi by 2 log 2, and solving and then getting the final answer I equal to minus pi log 2. I hope all of you understand all these questions. Try to complete all the questions of integration and try to complete this chapter by 4th of August, and then in the next week classes we will start a new topic based on this chapter only, which is application of integral, which will help you to understand how to calculate the area of curves using the integration. So all of you, please complete all your work. Thank you.